This short video will be about equivalent ratios. Do you think these are equivalent ratios? 3 to 2, 4 to 6, and 6 to 4. 3 to 2 and 6 to 4 are equivalent ratios. But 3 to 2 and 4 to 6 are not equivalent ratios. We're going to take a look at this in table form and see what's going on. All of these are equivalent ratios, 9 to 6, 6 to 4, and 3 to 2. If I put it in table form, I can see that going from 3 to 2 to 6 to 4, I use a multiplier of 2. And then I can see going from 3 to 2 to 9 to 6, the multiplier is 3. What would you expect the next piece of this table to be for an equivalent ratio? Well, I would probably say, if this is a multiplier of 3, the next one would be a multiplier of 4. With a multiplier of 4, 3 times 4 would be 12, and 2 times 4 would be 8. 12 to 8 is an equivalent ratio to 9 to 6, as is 6 to 4, as is 3 to 2. We can create a table of equivalent ratios. If I start with 3 to 2, and I use a multiplier of 2, I get 3 times 2 is 6, and I get 2 times 2 is 4. Going up, I would say, what is the next equivalent ratio? I would use a multiplier of 3. 3 times 3 is 9, and likewise 3 times 2 is 6. Let's generate some more equivalent ratios. Another equivalent ratio to 3 to 2 would be 12 to 8. Another would be, I use the multiplier 5. 5 times 3, 15. And then 5 times 2, I would get 10. What would the next multiplier be? 6. So 6 times 3, I would get 18. And then 6 times 2, I would get 12. 8 to 12 is an equivalent ratio to 3 to 2, and is also an equivalent ratio to any one of these other ratios, 9 to 6, 6 to 4, 12 to 8. What would this table look like for equivalent ratios of 4 to 5? Again, notice that I'm using the same multiplier. I'm going to use 5 4s and 5 5s. 5 times 4 is 20. 5 times 5 is 25. This is the multiplier 6. 6 times 4 is 24, and 6 times 5 is 30. Now you can look at ratios in the form of a fraction. If I were to take 4/5, can I say that's equivalent to 24/30? Well, as we know fractions, we know that we reduce them to lowest terms. So 24/30 in lowest terms, if I divide this by 6, and I divide this by 6, 6 goes into 24 4 times, and 6 goes into 30 5 times. And therefore, that is an equivalent fraction as well as an equivalent ratio if I had these in ratio form. Let's take a look at this problem. Find a number that makes the ratio 3 to 7 equivalent to something to 21. Well, when I look at the ratios and I line them up, the 7 aligns with the 21. So I ask myself, what do I multiply 7 by to get 21? Or what do I divide 21 by to get 7? And the answer is 3. So if I use that number 3, 3 times 3 is 9. Therefore, 3 to 7 is equivalent to 9 to 21. Let's try this one. Find a number that makes the ratio 3 to some number is equivalent to 15 to 35. Again, the 15 and the 3 are aligned, so how do I get from 3 to 15? Well, I multiply by 5, or how do I get from 15 down to 3, go backwards? I divide by 5. 5 being that number, the multiplier, the divisor. If I divide 35 by 5, I get 7. Therefore, 3 to 7 is equivalent to 15 to 35. That ends this little video clip on equivalent ratios. Enjoy the activity.